Ever wondered why tech giants like Google and Amazon are obsessed with linked lists? One wrong pointer movement can break your entire logic. In this video, we will cover linked list interview preparation questions and answers, data structures MCQ. Master linked lists for your next coding interview. This video covers 30 comprehensive multiple-choice questions designed to test your knowledge of singly linked lists, doubly linked lists, circular lists, and advanced algorithms like Floyd's cycle detection. In this video, we dive deep into 30 essential linked list questions that cover everything from basic traversal to complex pointer manipulation and memory management. Before we jump in, make sure to grab a pen and paper to trace these pointers along with me. What is the primary advantage of a linked list over an array? Option A. Faster access to individual elements using an index. Option B. Dynamic size and efficient insertions, deletions. Option C. Lower memory overhead per element. Option D. Better cache locality. The correct answer is B. Arrays have a fixed size and require O(n) time to shift elements during insertion or deletion. Linked lists are dynamic. They can grow or shrink at runtime. Inserting or deleting a node only requires updating pointers O(1) if the position is known, making them far more efficient for frequent modifications compared to arrays. In a singly linked list, what is the time complexity to delete a node given a pointer to that node? Not the head. Option A, O(1). Option B, O log n. Option C, O(n). Option D, O(n log n). The correct answer is C. To delete a node in a singly linked list, you must have access to the previous node to update its next pointer. Since a singly linked list only has forward pointers, you must traverse from the head to find the predecessor of the target node, resulting in O(n) time complexity. Note: a trick exists to copy the next node's data to the current and delete the next, but the standard deletion requires traversal. Which of the following is a disadvantage of a doubly linked list compared to a singly linked list? Option A. It cannot be traversed in reverse. Option B. Deleting a node is more complex. Option C. Increased memory usage per node. Option D. Searching for an element takes more time. The correct answer is C. Each node in a doubly linked list, DLL, stores 2 pointers, next and previous, instead of 1. This extra pointer increases the memory footprint of every single node in the list while it allows for bidirectional traversal and easier deletion of a given node. The trade-off is higher space consumption. What is the identifying characteristic of a circular singly linked list? Option A. The head node's previous pointer points to the tail. Option B. The tail node's next pointer points to the head node. Option C. Every node has 2 next pointers. Option D. The list has no nodes. The correct answer is B. In a standard singly linked list, the last node, tail, points to null. In a circular singly linked list, the tail node's next pointer is updated to point back to the first node, head. This creates a loop, allowing continuous traversal without ever hitting a null termination. What is the time complexity of searching for an element in an unsorted linked list of length n? Option A, O(1). Option B, O log n. Option C, oxygen mononitride. Option D, O, n squared. The correct answer is C. Unlike arrays, linked lists do not support random access. To find a specific value, you must start at the head and follow the pointers one by one until you find the target or reach the end. In the worst case, element at the end are not present. You visit all n nodes, leading to O, n complexity. If head is the first node, what does head next equals head next effectively do? Option A, deletes the head node. Option B, deletes the second node in the list. Option C, swaps the first and second nodes. Option D, creates a circular reference. The correct answer is B. By setting the head's next pointer to the node after its current next, you are bypassing the second node entirely. The second node is no longer reachable from the head, effectively removing it from the sequence. In languages with garbage collection, this unreferenced node will eventually be deallocated. Which algorithm is commonly used to detect a cycle in a linked list? Option A, binary search. Option B, Dijkstra's algorithm. Option C, Floyd's cycle finding algorithm. Option D, quicksort. The correct answer is C. Floyd's cycle finding algorithm, also known as the tortoise and hare algorithm, uses two pointers moving at different speeds. 1 step versus 2 steps. If there is a cycle, the fast pointer will eventually catch up to the slow pointer within the loop. If the fast pointer reaches null, there is no cycle. In C++, what happens if you delete a node but do not set the previous node's next pointer to null or the next node? Option A, memory leak. Option B, dangling pointer. Option C, segmentation fault. Immediately. Option D, the list automatically repairs itself. The correct answer is B. If you free the memory of a node but the previous node still holds that memory address in its next field, that pointer is now dangling. It points to a memory location that is no longer valid. Attempting to access this pointer later will lead to undefined behavior, often resulting in a crash or data corruption. Which of the following is not a type of linked list? Option A, singly linked list. Option B, doubly linked list. Option C, circular linked list. Option D, binary linked list. The correct answer is D. Singly, doubly, and circular are standard variations of linked lists. A binary linked list is not a standard term. You might be thinking of a binary tree, where each node has two children, or a doubly linked list while a tree uses nodes and pointers. It is a hierarchical structure, not a linear linked list. To implement a queue using a linked list, where should the NQ and DQ operations ideally take place for O? 1. Efficiency? Option A, NQ at head, DQ at head. Option B, NQ at tail, DQ at head. Option C, NQ at head, DQ at tail. Option D, NQ at tail, DQ at tail. The correct answer is B. In a queue, FIFO, we add at one end and remove from the other. If we maintain a tail pointer, we can NQ at the tail in O. 1. DQing from the head is also O. 1. As we just move the head pointer, Dequeuing from the tail in a singly linked list is O (n), because we need the node before the tail to update the tail pointer. What is the space complexity of reversing a singly linked list iteratively? Option A, O, 1. Option B, O, log n. Option C, O, n. Option D, O, n squared. The correct answer is A. Reversing a linked list iteratively involves using 3 pointers: previous, current, and next, to flip the direction of the next pointers. Since we only use a constant number of extra pointers regardless of the list size, the auxiliary space complexity is O, 1. In a doubly linked list, how many pointer changes are required to insert a new node in the middle? Option A, 2. Option B, 3. Option C, 4. Option D, 6. The correct answer is C. To insert node n between nodes A and B, 1. N. Next points to B. 2. N. Previous points to A. 3. A. Next points to N. 4. B. Previous points to N. These 4 pointer updates ensure the bidirectional links are correctly established. What is the purpose of a dummy or sentinel node in linked list implementation? Option A. To store the size of the list. Option B. To simplify edge cases like inserting, deleting at the head. Option C. To act as a backup of the data. Option D. To speed up search operations. The correct answer is B. A dummy node is a non-data node placed at the start of the list. It ensures that the head pointer never changes and that every real node has a predecessor. This eliminates the need for if head equals null or if node equals head checks in insertion and deletion logic. Linked list nodes are typically allocated in which part of the memory? Option A, stack. Option B, heap. Option C, data segment. Option D, code segment. The correct answer is B. Because linked lists are dynamic data structures that grow and shrink during execution, their nodes are allocated on the heap using dynamic memory allocation functions, like new in C++ or malloc in C. What happens if you try to traverse a singly linked list in reverse order using only recursion? Option A. It is impossible. Option B. It requires O(n) auxiliary space due to the call stack. Option C. It is faster than iterative forward traversal. Option D. It changes the actual structure of the list. The correct answer is B. You can print a list in reverse by calling the function recursively for node next before printing node data. However, each recursive call adds a frame to the system stack. For a list of size n, this results in O(n) space complexity, which can lead to a stack overflow for very large lists. Which data structure is most suitable if you need to frequently add elements to the beginning of a collection? Option A, array. Option B, singly linked list. Option C, binary search tree. Option D, hash table. The correct answer is B. Adding to the beginning of an array requires shifting all existing elements, taking O(n) time. In a singly linked list, you simply create a new node, point its next to the current head, and update the head pointer, which is always 1. In a circular linked list, how do you verify the end of a traversal starting from the head node? Option A. Check if current next equals null. Option B. Check if current next equals head. Option C. Check if current equals null. Option D. Check if current data equals -1. The correct answer is B. Since there is no null in a circular list, a standard while cur equals null loop will run infinitely. The correct way to stop is to check if the next node is the node you started from, the head. To find the middle of a linked list in a single pass, which strategy is most effective? Option A. Count all nodes. Then restart and stop at count 2. Option B. Use 2 pointers, one moving twice as fast as the other. Option C. Use a hash map to store node positions. Option D. Linked lists cannot be traversed in a single pass to find the middle. The correct answer is B. Using a slow pointer moves 1 step, and a fast pointer moves 2 steps. When the fast pointer reaches the end of the list, the slow pointer will be exactly at the midpoint. This is a classic single-pass algorithm. Which data structure is traditionally used to represent polynomials with many zero coefficients? Sparse polynomials. Option A, array. Option B, linked list. Option C, queue. Option D, stack. The correct answer is B. In an array-based polynomial representation, you need space for every power. If you have x caret 1000 plus 1, you'd waste 998 slots. A linked list only stores nodes for non-zero terms, coefficient and exponent, saving significant memory. What is the time complexity to concatenate two singly linked lists of size m and n, given only the head pointers? Option A, 1. Option B, m. Option C, oxygen mononitride. Option D, m plus n. The correct answer is B. To concatenate, you must find the tail of the first list, size m. To point it to the head of the second list, finding the tail of the first list takes m time. Once found, the link update is 1. A node in a singly linked list contains at least which two fields? Option A, data and previous pointer. Option B, data and next pointer. Option C, next pointer and previous pointer. Option D, data and index. The correct answer is B. A singly linked list node must store the actual value, data, and a reference pointer to the next node in the sequence. It does not store an index, unlike arrays, or a previous pointer, unlike doubly linked lists. What is the result of deleting the only node in a singly linked list? Option A, the head becomes null. Option B, the list becomes circular. Option C, a segmentation fault occurs. Option D, the next pointer points to itself. The correct answer is A. When the only node is deleted, there are no more nodes for the head to point to. Therefore, the head pointer must be updated to null to indicate an empty list. Which operation is significantly easier in a doubly linked list than in a singly linked list? Option A. Searching for a value. Option B. Inserting at the head. Option C. Deleting a node given only a pointer to that node. Option D. Finding the length of the list. The correct answer is C. In a DLL, since each node has a previous pointer, you can access the predecessor of any node directly. In a singly linked list, you would have to traverse from the head to find the predecessor, making the DLL approach O(1) versus O(n). In a language like Java or Python, what happens to a linked list node that is no longer pointed to by any other node or variable? Option A. It remains in memory until the program ends. Option B. It is automatically reclaimed by the garbage collector. Option C. It causes a system crash. Option D. It is moved to the stack. The correct answer is B. Java and Python use automatic memory management, garbage collection, when a node's reference count drops to 0 or it becomes unreachable from any root reference. The garbage collector identifies it as trash and frees the memory automatically. Which sorting algorithm is generally preferred for linked lists? Option A. Quick sort. Option B. Heap sort. Option C. Merge sort. Option D. Selection sort. The correct answer is C. Merge sort is preferred for linked lists because it can be implemented without requiring extra space. Unlike arrays where merge sort needs O(n) auxiliary space. Additionally, merge sort doesn't require random access, which fits the sequential access nature of linked lists perfectly. In a linked list, the head is Option A. The last node of the list. Option B. A pointer to the first node of the list. Option C. The middle node of the list. Option D. A variable storing the total number of nodes. The correct answer is B. The head is the entry point to the linked list. It is a pointer, or a reference, that stores the memory address of the first node. If the head is null, the list is considered empty. Which of the following is a common application of a circular linked list? Option A. Undo, redo functionality in editors. Option B. Implementing a round-robin scheduler in operating systems. Option C. Representing a hierarchical file system. Option D. Storing data for binary search. The correct answer is B. Round-robin scheduling requires cycling through a list of processes repeatedly. A circular linked list allows the CPU to move from the last process back to the first one seamlessly, making it an ideal structure for this application. What is the time complexity to insert an element at the end of a singly linked list if you only have the head pointer? Option A. O(1). Option B. O(log n). Option C. Oxygen mononitride. Option D. O(1) if the list is empty, else oxygen mononitride. The correct answer is C. Without a tail pointer, you must start at the head and traverse all n nodes to find the last node so you can update its next pointer. This traversal takes linear time. O(n). If you are given a doubly linked list, how do you swap two adjacent nodes, A and B, where A is before B? Option A. Only swap their data fields. Option B. Update two pointers. Option C. Update 4 pointers. Option D. Update 6 to 8 pointers depending on surrounding nodes. The correct answer is D. Swapping two adjacent nodes A and B in a DLL involves updating 1. The next of the node before A. 2. The previous of the node after B. 3. A's next and previous. 4. B's next and previous. Because each node has bidirectional links, you must carefully reassign multiple pointers to maintain the list integrity. Which of these is true about a null pointer in a linked list? Option A. It indicates the start of the list. Option B. It is used to store the value 0. Option C. It signifies the end of a non-circular list. Option D. It is only used in doubly linked lists. The correct answer is C. In singly and doubly linked lists, non-circular, the next pointer of the very last node points to null. This acts as a sentinel value telling the traversal algorithm that there are no more nodes to process. That wraps up our 30-question deep dive into linked lists. Whether it's pointer manipulation or time complexity, these are the concepts that interviewers love to test. If you found this helpful, hit that like button and subscribe for more DSA deep dives. For a full interactive practice exam experience with certification, check out the link in the description below.